Good day, grade 9s. I'm Ms. Todd, and today's lesson will be about the reactions of acids with bases, part 3. For this section, we are going to be looking at one specific reaction that occurs between metal carbonates and what the chemical reaction entails. So let's have a look. This section, we are going to be looking at the general reaction of an acid with a metal carbonate. When acids react with metal carbonates, a salt, water, and carbon dioxide forms. Now remember, if we go back to previous knowledge, metal carbonates are bases, and that's what we did in the metals reacting with oxygen sections. So an easy way to identify if carbon dioxide is present, it usually causes a bubbling or fizzing during a reaction. So this is the section now where we are adding a third product to our general equation, and that product will be carbon dioxide. In this section, we have a positive test for carbon dioxide. The positive test is that clear lime water will turn a milky color when it is bubbled through. So clear lime water is over here. It is clear in color, and if carbon dioxide is bubbled through or blown through it, it turns a milky color. This is the positive test for carbon dioxide. Let's have a look at what some of the examples are of metal carbonates. Metal carbonates can be found in substances or items like chalk, limestone, bicarbonate of soda, and marble. These are all examples where metal carbonates are found in. Limestone is quite an important one, which we'll go into detail with. Limestone is an example of metal carbonate because it is made up of Ca, which is calcium, C, which is carbon, and O, which is oxygen. That gives us the name calcium carbonate, but we use the word limestone as the common name of it. And it is actually used in agricultural areas or agricultural farmlands to neutralize the soil after the pH of the soil has decreased as a result of acid rain. So in the previous section, we mentioned how acid rain is formed. Limestone is using limestone by turning it into the soil or adding it to the soil is one way which we can combat the effect of acid rain on soil. Let's have a look at our first example of the reactions of acids with a metal carbonate. Example number 1 is calcium carbonate plus hydrochloric acid gives us calcium chloride, carbon dioxide, and water. Our chemical equation is CaCO3, which is calcium carbonate, plus HCl, which is hydrochloric acid. Number 1 is calcium and number 2 is CO3. The reason why we make the entire CO3 as number 2 is because it is a polyatomic ion. Number 3 is hydrogen for hydrochloric acid, and number 4 is chlorine of hydrochloric acid. Now for this section, we are only going to apply the first rule of the previous rules that we have done for the reactions of metals and acids. So number 1 is going to bond with number 4 to give us calcium chloride, or CaCl2. The reason why it's 2, calcium has a valency of +2, chlorine has a valency of -1, so it goes to CaCl2. Our other two products is then water and carbon dioxide. The way in which we get these formulas is by writing out H and O and C and O, and we are crossing over the valencies as well. But as long as you remember that it's carbon dioxide and water. Let's have a look at our second example with the reaction of acids and metal carbonates. Example 2 is magnesium carbonate plus sulfuric acid, which gives us magnesium sulfate, which is our salt, and carbon dioxide and water. Our chemical equation looks like this. MgCO3 represents magnesium carbonate and H2SO4 represents sulfuric acid. Number 1 is magnesium and number 2 is CO3 because it is a polyatomic ion. Number 3 is H2 of sulfuric acid and number 4 is SO4 because it is a polyatomic ion. So again, the only rule we are applying is that number 1 bonds with number 4 to give us MgSO4. The valency of both Mg and SO4 is +2 and -2, so they cancel each other out. So our answer remains as MgSO4. And we have water and carbon dioxide as a product. Again, to show you how we get H2O, this H2 of sulfuric acid bonds with one of the oxygens of carbonate to give us H2O. That then leaves us with CO2 over here. Leaves us with CO2 over here, and our answer there is then CO2.